Hello everybody and welcome back. Today we're going to be in section 2.1. We're talking today about organizing qualitative data. So what we're going to do is learn how to organize qualitative data into tables, and then we will construct a couple of bar graphs together, and I'll show you how pie charts are constructed, although that's not something that you'll be expected to do by hand on a test or anything, because you really need a compass and a protractor for that. But we will just talk about how they are made. So here we go. Okay, now in chapter 1 we talked about how to collect data from observational studies or surveys or designed experiments. And after you collect the data, you have to organize it into some manageable form so you can get information from it. Data that is not organized yet is referred to as raw data, and what it looks like to us is just a list of numbers. And it's very difficult to look at a list of numbers and draw any meaningful conclusions about that list of numbers. So we need to talk about some ways we can organize the data and make sense of it. Some ways we can organize data are tables, which we'll talk about in this section, and graphs, which we'll talk about in this section and the next one, and numerical summaries such as mean, median, mode, and all the rest, and we'll look at those in chapter 3. Now we said we're organizing qualitative data in this section, and remember, qualitative data is categorical data. Qualitative data is usually non-numeric, although it is possible for numeric data to be qualitative, such as zip codes and phone numbers. Most qualitative data, and probably all the qualitative data that we'll deal with, is non-numeric. The way we organize this data is we make a frequency distribution or a frequency table. And the way we'll do it is we'll list each category of data, and then we'll tally the number of occurrences for each category of data. Here's an example. A physical therapist wants to determine types of rehabilitation required by her patients. To do so, she obtains a simple random sample of 30 of her patients and records the body part requiring rehabilitation. Construct a frequency distribution of location of injury. So here we have just a table of raw data. And what we're going to do is list each body part, and then we will tally up how many times each one occurs in the list, and then we'll get a frequency. That is, we will sum up the tally for each category. So I'm looking at the list here and I see back, and then I'm going down the list. I see wrist, then elbow, hip, neck, shoulder, hand, groin. Okay, so all of these we have in the list, and the order that we put them in is not important. You could alphabetize them if you wanted to, but why bother, really? You can always do that later, but the important thing is just to get them all listed. And now let's tally. Now, whether you go down the list or across is really up to you. I do it different ways depending on how the table's arranged, but if the table is shorter across, I'll usually go across. So that's what I'm going to do here. Notice that the first 3 entries are back, back, hand. So over here, I'll put a mark for back, back, hand. Okay, then the next row says wrist, back, groin. So I'll put a mark for wrist, and then another mark for back, and then groin. And then elbow, back, back. So that's going to be 1 for elbow, and then 2 for back. Now I'm sure you're familiar with this, but your 5th mark you want to make a cross. So that way your data will group itself into 5s, and it'll be easy then to count. Okay, so that's the last one from that 3rd row, and then we'll have back, shoulder, shoulder, and hip, knee, hip, neck, knee, knee, shoulder, shoulder, back, 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 back. Sound like Chris Berman, don't I? And then knee, knee, back, and then hand, back, wrist. Okay, so these are our tally marks, but we're not finished yet, because what you really need to do is total the data up so it's usable. So here I have 5, 10, 12 entries for back, 2 for wrist, 1 for elbow, 2 for hip, 4 for shoulder, 5 for knee, and then 2 for hand, 1 for groin, and 1 for neck. And honestly, this part of the table is scratch work. So when you put a frequency table in MyLabs Plus, I do not expect you to type the tally marks. It will be enough if you give me the categories and the frequencies. Now let's talk about relative frequency. The relative frequency is the proportion or percent of observations within a category, and it's found using the formula relative frequency equals frequency divided by the sum of all frequencies. Now this says proportion or percent. Proportion is the decimal value, and percent has been multiplied by 100 and has a percent symbol on it. We almost always use the proportion, but you could use the percent if you really needed to. We will usually stick with proportion. Now, a relative frequency distribution lists each category of data with the relative frequency. So a frequency distribution lists the frequencies, and a relative frequency distribution lists the relative frequencies. But it's the same type of distribution as you're about to see in our next example, where we're going to take our frequency table that we just found and turn it into a relative frequency table. And here is that frequency table. And so now we're going to calculate the relative frequency. Remember that the original number of values in our raw data was 30. So we're going to divide each of these frequencies by 30. For the first category, 12 divided by 30 is 0.40. For the second category, 2 divided by 30 is 0.067. There's no set number of decimal places you need to keep here. I usually keep 3. So up here, I just didn't write the third one because I didn't need it, but I usually round off at the third decimal place. So for this next category, 1 divided by 30 will be 0.033. And then 4 divided by 30 will be 0.133, and so on down the table, just dividing each frequency by 30. And notice that the sum of the relative frequencies is 1. That's because if these were in percents, they would need to add up to 100% because these frequencies are 100% of the data values. So these decimal values are going to add up to 1. Now, you may not get exactly 1. It depends on the rounding. You could come up with 0.999 or 1.001, something like that. But if it doesn't come up very, very, very close to 1, you've done something wrong, and you'll want to check on that. Now let's talk about bar graphs. A bar graph is constructed by labeling each category of data on either the horizontal or vertical axis, and the frequency or the relative frequency of the category on the other axis. Typically, the way we see it is with the bars going up, and so the categories will be across the bottom, and the frequencies will be up the vertical axis. Our bar graphs always contain rectangles of equal width, and the height of each rectangle represents the category's frequency or relative frequency. The frequency axis needs to go not much higher than the tallest bar. In other words, if your tallest bar only needs to be 10 units high, there's no sense having your vertical axis go all the way up to 20, because you need to make use of the space in your graph. So the tallest bar should go almost to the top of your vertical axis. And the bars on the bar graph must be separate. They must not touch. This is a common mistake because there are some graphs where the bars have to touch, but when the data is qualitative, we never let the bars touch. So on a bar graph, the bars must be separate. For our next example, we are going to construct a bar graph using the frequency distribution that we came up with in the first part of example 2. So let's draw a horizontal and a vertical axis, and the first thing we'll need to do is label our axes. I'm going to start with the vertical axis. I noticed that my tallest bar is going to need to be 12 units tall. So I've decided to count by twos here. And so I've got 2, 4, 6, 8, 10, 12. Notice that your tallest bar needs to come almost up to the top of the space that you have available. There would be no sense in drawing a bar graph where the tallest bar only comes up to here, because then you would be wasting all this space. So whatever the tallest bar is, go ahead and make that like about the top of the vertical axis. And then we'll need a tick mark for each category, and we'll go ahead and label those with the categories that we have from our frequency distribution. And so our first bar is 12 units tall, so I'll draw that first rectangle centered over that tick mark, 12 units tall. And now remember that the bars are not supposed to touch. They must not touch. So the second bar is going to be 2 units tall. That'll bring it to about here. And the third bar is going to be 1 unit tall, so about half the height of this second one. And then the next bar is 2 units tall, then up to 4, which will bring it to about here. And then 5 units tall would be halfway between 4 and 6. And then 2, 1, 1. And that is our frequency bar graph. Now let's look at a relative frequency bar graph. So I'm going to start with, again, a pair of axes, and I notice that my tallest bar is going to be 0.40 units high, so it seemed convenient to me to count by tenths. And I also went ahead and marked halfway in between each of the tenths. And now again, tick marks for each of the categories on the horizontal axis. And our first bar will need to be 0.4 units tall, so that'll bring it all the way up here. The second bar is 0.067, which looks bad, but remember the graph is not that exact, so you really are not measuring to the third decimal place. We just see that if this first tick mark is 0.1, then halfway between the axis and the tick mark would be 0.05. So 0.067 would be just a little above that. So I'll let that bar come to about right here. And then the next one is 0.033, which would be about 2/3 of the way from the axis to this 0.05 line. And, you know, again, it's not that exact. If this is 0.05, there's not a lot of room to play with here. I know 0.03 is less than that, so I just made it a little shorter. And the next one is 0.067, so that's the same as the second one. And after that, 0.133. Well, here's 0.1, and this little tick mark here would be 0.15. So 0.13 would be somewhere in here. And then 0.167, if this is 0.15, 0.167 is going to be a little above that. And then 0.067, that's this height again. And 0.033 is this height again. And so there is our relative frequency bar graph. And I'm going to flip back to the frequency bar graph that we did. And I just want you to see that the graph has the same shape. See that? So when you construct a relative frequency bar graph, it's not going to really look any different from the frequency bar graph. The only thing that's actually different is the vertical axis is labeled differently. And now let's look at one more type of bar graph. This is the Pareto chart. A Pareto chart is a bar graph where the bars are drawn in decreasing order of frequency or relative frequency. You can have either one that you want. And we're going to use the frequency data from the example we've been working on. So I'll go ahead and make my two axes. And I remember that the tallest bar is 12, so I've got that vertical axis labeled. I can go ahead and put the tick marks on the horizontal axis, but I'm not going to put the labels yet because we need to put these categories in order from the largest frequency to the smallest frequency. Now I know that the tallest bar was 12, so I'm going to do that one first, and that's the back category. And then after that, the next largest category is the knee, and that one's 5 units tall. So I'll draw that rectangle here, and remember to label it. And the next tallest bar is the shoulder, so that's 4 units tall. After that, we have 3 bars that are tied. So the wrist, the hip, and the hand all were 2 units tall. So I'll draw 3 bars that are all 2 units tall, and we'll label those wrist, hip, hand. And the order here doesn't really matter. You could put these in any order because they're all the same height. And then the last 3 are elbow, groin, and neck. And those are all 1 unit tall. So notice that our Pareto chart goes from tallest bar to smallest bar. And that's the only difference between a Pareto chart and a regular bar graph. And now just a little bit about pie charts, although we will not be drawing our own by hand. A pie chart is a circle divided into sectors. Each sector represents a category of data, and the area of each sector is proportional to the frequency of the category. So now notice, pie charts are good for categorical data where the categories add up to 100%. In other words, they can't have categories that overlap. And you can never do this with a table where the data add up to more than 100%. For example, if people are asked to choose what candidate would you be willing to vote for, well, people might have multiple candidates they'd be willing to vote for, and so your data are not going to add up to 100%. You might have 80% say they would be willing to vote for candidate A, and 70% say they would be willing to vote for candidate B. Not that they plan to vote for them, because you can only plan to vote for one, but they might be willing to vote for more than one candidate, especially, you know how it is during primary season. So you need to only use pie charts when the categories are going to add up to 100%. Use a pie chart when you want to be able to compare the categories to the whole, but it's not as important to be able to compare the categories to each other. If you really want to focus on comparing categories to each other, use a bar chart. But if you want to focus on comparing the categories to the whole, use a pie chart. And to calculate the degrees for a sector, you multiply the relative frequency by 360 degrees, because remember there are 360 degrees in a circle. So here is an example of a pie chart. The following data represent the marital status in millions of U.S. residents 18 years of age or older in 2006. Draw a pie chart of the data. Now you can see that we already have the pie chart here, so we won't really be drawing it ourselves, but we're just going to do all the calculations that would be necessary to draw one ourselves. So we've got the frequencies here, and we know that in order to calculate the number of degrees in each sector, we need to do relative frequency times 360 degrees. So we'll need to get the sum of these numbers so we can get the relative frequencies. If you add these 4 numbers, you find the sum is 219.7. Now if you divide each of these numbers by 219.7, you'll get a relative frequency. And I'm just rounding each of these relative frequencies to 3 decimal places. That's kind of standard. Okay, now, before we go on and calculate the number of degrees in each sector, let's just pause and notice that if we add all these relative frequencies together, they add up to 1. That's always important to remember, because that way you can check yourself and see if you made like a little typographical error or something like that. Notice that on the pie chart, they've already got the sectors labeled with the appropriate percent, but I'm going to use the number that we have rounded to 3 decimal places here instead of using their rounded off value. Mine is rounded, but it's not rounded quite as far, so this will give us a little more precise number to work with. Okay, so here we go. 0.252 times 360 is going to give us 90.7. And you can look at that and tell that it's very close to a 90-degree angle. And then 360 times 0.581 for the married category gives us 209.2 degrees. And it's clear that this is more than 180 degrees. And then for the widowed category, 360 times 0.063 is giving us 22.7 degrees. And for the divorced category, 360 times 0.104 is going to give us 37.4 degrees. And if you add all of the degrees up, we should be very close to 360, if not exactly 360.